Good afternoon, ladies and gentlemen, or good morning, depending on which class that you are in. Today, we're trying things a little bit differently. I grouped you guys, half the class to be out in the shop, the other half, this is your assignment for today. We're going to try this as I mentioned to you guys previously. This is going to take some of you guys being adults and using that capacity. And I know that you can do that. But you're just going to, like I said, just make sure that you keep up with that, because if we want to go out in the shop, we're going to have to change things around this year, and we're not going to all be able to go out at once. We're not only going to be able to have one day out there where everybody gets to work. We're going to have to split it up like this. And if it comes down to it to where the work is not getting done, whenever you're not welding, then we're not going to be able to go out in the shop anymore. So, like I said, it's a weird year. It's just the way that things are going to have to play. So, your assignment for today is to do this Nearpod on this topic, which is energy. Energy is going to be the main focus of a lot of what we talk about in this course. It's constant, it's always there, it's always most likely what we're striving to accomplish then. So, fill in the answers to the Nearpod here. If you don't know an answer, you're probably not really paying attention. So you probably need to go back and rewatch the segment that you missed or whatever it is. It wouldn't hurt to take a couple of notes as well on just a piece of paper or whatever it is, just so that you have some of this setback as well written down for you to hard copy and go back and look at. All right, so let's get started. So our main thing we're going to talk about, obviously, like we said, is energy. So we need to know what energy is, and that is the ability to perform work or cause change. Work is a change in position. So moving a pencil, okay, carrying your backpack, opening a door, walking up steps, all of those are an example of work because it's a change in our own positions. Sometimes we don't always think about it being work because we're not gaining muscles. We're not using muscles. It takes me 0 muscles really to lift this pen. So we don't always consider it work because it's not quote unquote hard. And we often think of work as being hard. But it's that change in a position. That's all that it is. So some agricultural examples of work you can think about and record here in just a second. All right, so 2 types of energy. We have potential energy, which is just what it sounds like. It has the potential to release energy or for that energy to be used, but that energy is not released. It's stored somewhere. It's held back for a later date. So you can think about water behind a dam. If we blow that dam, that water starts to rush, or if we open the dam gates, I guess we don't have to be quite so dramatic. If we just open the dam gates a little bit, let that water flow, that water then is our energy and it's performing work. A wagon on top of the hill, same thing. It's just sitting there. It's not doing anything, but it has the potential. If we come by, we give it a little push, that wagon starts to go down the hill, then bam, now we have kinetic energy. Gasoline ready to combust, sitting in your gas tank, it's not doing anything. It's just sitting there. But once it does combust, then it's doing the kinetic energy. It's actually performing work. So kinetic energy is energy that is being used to perform work. So all of those potentials I guess I should say, it won't for sure, but it does have that potential to turn into kinetic energy. So gasoline combusting in an engine, that is kinetic energy. It's doing the work. It's moving us forward or backwards or whichever direction we're trying to go in our car. Engine powering a tractor in a field, that's kinetic. Its work is helping, or its energy rather, is helping us to do work. So those are our 2 types. We have forms of potential energy, and there's a couple of these. We have chemical energy, which is just energy that is stored between bonds of atoms. So if you look at this food here that I've got, this all has the potential to turn into energy inside of my body that will then allow me to do work, like all the moving around that I'm doing here. However, in its form in itself, it's nothing. It has the potential, but it's not doing anything. For it to turn into kinetic energy, or for this spicy buffalo pack to be used, then I have to ingest it, and then my body, through chemical reactions, absorbs that and then is able to use that energy for work. Same thing with batteries. They just sit there. They don't have it. They don't have what it takes. But once you put it in a remote or a game console system or a fake candle, whatever it is, once you put it in there and that machine or whatever you want to call it has the potential then to harvest that energy and then use it to light a light bulb, to play your game controller, to turn the channel, whatever it is, that's your options. Fuel is the same way. It's a chemical energy. It takes a chemical reaction to make that fuel combust so that we can move. Then you have gravitational force. Very, very easy because everything has a gravitational force to it, which is the pull of it to the earth. So no matter how many times I pick up this pen, once I drop it, it's going to fall. And that's good. That's what we want. If it's not, then we have something really weird going on and we've got issues. Or we're living on the moon, which we're not. So that is gravitational energy, just the attractive force that it has to fall to the earth. Other forms, we have non-renewable and renewable resources. You guys have probably heard about this since you were in second grade. Renewable are things that come back all the time or constantly, or they're readily available. We always have them. So you're looking at wind, because wind energy helps us to produce electricity through the giant turbines. You have ethanol, which is biofuel to power vehicles. So you can make that from corn, you can make that from other crops. If we run out, we just plant more and then we can create more ethanol. Water, a lot of dams produce energy. That's the whole point behind most of them. So we can use that water. If we are running low, we can pump that water back up to the top of the dam and then let it flow back through to get more energy. It's renewable. We can use it over and over and over again. We're not going to ever run out of it. Or if we do, we're dead anyway, so who cares? Non-renewable are the things that we can't just plant to get more of, or they have the potential to run out. So we're looking at fossil fuels. That's obviously what we use right now for gasoline. So once we're out of dinosaur bones, we're done. That's it. We're going to have to come up with a different energy source. Same thing with coal. Coal is burned to produce steam that's converted to electricity. Steam is very efficient. However, coal in itself, we're getting to that point, is not, because we're going to run out of coal at some point. So those are our difference between renewable and non-renewable. All right, so those are forms of potential energy. Now we're going to look at forms of kinetic energy. If you remember, we said kinetic energy is the energy that's actually performing work. It's causing a movement. So we have all of these options. We have electrical, mechanical, thermal, gravitational, sound, and light. So let's talk about them. Electrical is the movement of electrons through a conductor. The most common source of energy is electrical energy. If you think of most things we have, you plug them in. That's the way it goes. You plug in your phone to make it work. You plug in your hairdryer. You plug in your TV. You plug in your game system. Whatever it is, a lot of cases, electricity, that's our number one route. That's what we like to use. So it powers lights, appliances, tools, anything you can think of, refrigerators, whatever. A lot of that is used for electrical energy. So you guys should be very familiar with that. Mechanical energy is energy that's produced from a physical movement. So you've seen these wind turbines here in this picture. If those aren't moving, they're not performing any work. So mechanical energy is something has to move in order to get the work. So that turbine being moved by the wind, a skid steer actually lifting a load, the pistons moving up or down. Just because you have pistons and you have gas doesn't mean your engine is going to work. You have to have those pistons moving up and down. That's what that mechanical movement is, what's going to turn that fuel into energy. So we have to have that mechanical energy. Thermal energy. Thermal is what we know as heat. So it's produced by the movement of atoms. When fuels are burned, energy is released in the form of heat. Thermal energy is released every time energy is transferred. So no matter what you're doing, if energy is being released, you're going to feel a heat, you're going to feel a change, and that's our thermal energy that we have. All right, so that's thermal energy. That's whenever you feel some sort of a change. So when you're working with something and you start to feel that heat, that is that thermal energy. You could think of probably 100 different things. If I'm running my fingers together, that's thermal energy. You can feel your palms start to get warm. That's the thermal energy. Then what we're looking at next, maybe, is gravitational energy. So we've talked a little bit about this, and again, that's the attractive force. Now you notice this was also in our potential, because if I'm holding this up here, it's potential energy. Once it's falling, it's kinetic energy, and it's still, they're both gravitational force, and so that's why we see this in both places. The gravitational energy is dependent upon the mass of the object. This pin is very, very small. I could time the amount of time it takes to drop. If I have a 10-pound weight and I drop it, it's going to drop a whole lot faster and a whole lot harder. So our gravitational energy is then dependent on the mass. Gravitational force, as you guys know, that's what keeps us grounded to the earth, so super handy to have. Sound energy travels in the form of waves, sound waves. We've heard those. So they have to travel through some form of matter. Some sounds can be damaging to the ear. That's important for ear protection purposes, so that you know what those decibels are, so that you know when you need to wear earplugs and when you don't. For example, when you're mowing the lawn, you should be wearing earplugs, not earbuds that are blasting music as loud as possible, but actual ear protection. Same thing, running a chainsaw, shooting guns, any of that kind of stuff, that it can be damaging to the ear. So it's important to realize that to keep your health of your ears, obviously. And then we have light energy, which travels in, the form of waves. It's electromagnetic radiation. It's emitted from hot objects in a lot of cases. So this contains photons, which is small little packets of energy. So this is where we get our solar energy. That light, that heat can be absorbed through those solar panels, and then we can turn around and use that for energy. All right, so that's the end. Make sure you filled this in. If you were unsure of a couple of things, feel free to ask a couple of questions. And that's it. Thank you guys, and we will see you in class. Bye-bye.